Hey everybody, today we're finally going to finish section P.1. It's been a long section and we're near the end. But again, we're going to be reviewing a lot of things you probably know already, but it's good just to go over them to make sure we've got a good foundation before we start this year. All right, we're going to start here with the properties of equality, which basically sums up that whatever you do to one side of an equation, you have to make sure you balance it by doing it to the other side of the equation. So we start here with the same instructions. A, B, and C can be real numbers, they can be variables, or entire algebraic expressions. Either or all are fine. All right, property number 1 says, if I have an equality like this, if A equals B, then A plus or minus C, and notice what I did. I took the A on one side and I added or subtracted C. It just means you have to do it on the right-hand side too. So that equals B plus or minus C. So if you add or subtract to the left side, you have to balance it out by adding or subtracting the same amount to the right side. And that just makes sense to balance out the equation. Number 2, if A equals B again, then A times C, well, look what I did to the left side. I multiplied the left side by C. Well, then I have to multiply the right side by C, right? So it should be B times C. If I multiply one side by a number, whether it's positive or negative, I just have to make sure I multiply the other side as well. And these you can use any kind of numbers to use for examples, but they do work fine. Number 3. All right, now we're actually kind of going backwards. If you have A plus or minus C on one side and B plus or minus C on the other side, then since we have these same terms on the right side, we can eliminate them by either adding or subtracting them because they're the same, and you should be left with, therefore, A equals B. Because we added or subtracted the same amount on both sides, then the original A must equal B as well. And similarly, 4 is sort of the reverse of 2. So if I take A times C and B times C, then therefore, since we have C on both sides, we can equally divide them from both sides, and you should just get A equals B. Now I said you can divide them by both sides, but remember, we can't divide ever by 0. Dividing by 0 is always bad. So as long as C doesn't equal 0, then we can divide both sides and get A equals B. Okay, so just in general with these 4 here, friends, just know that whatever you do to one side of an equation, you have to do to the other side as well. How about some properties of one of our most famous numbers, of 0? Even though 0 is really nothing, literally, there's a lot of neat things we can do with it. Same rules. A and B are real numbers, variables, algebraic expressions. Property number 1. All right. Well, in general, guys, when you add 0 to a number, you just get the same number out. So A plus 0 is A. So what do you think A minus 0 is? That's also A. So 0 is great. Add it or subtract it, you get the same number out because you're not adding or subtracting anything. Ooh, but how about for number 2? When you multiply anything by 0, you always get 0. Whether you're multiplying 5 times 0 or negative 1 billion times 0, you always get 0 back out. Rule number 3. Now, I want you to look at rule number 3, and then before I solve that, can you look at rule number 4 and look how similar they are? So it looks like they're going to be maybe the same answer, but they are very different. I'm going to put stars next to them because these are often causes for errors and confusion. So watch carefully on 3 and 4. You can divide by A and have 0 on top. 0 divided by, for example, 4. Or 0 divided by negative 2. Because basically, if you remember, folks, with division, you're asking yourself, how many times does the bottom number divide into the top number, right? How many times does 4 divide into 0? How many negative 2's can I put into 0? And the answer is always, as long as 0 is on top, the answer is 0. Number 4, dividing by 0 is very bad, like we said up here on top. Dividing by 0 is bad. We just can't do it. So we say it's not defined, or we say it's undefined. And use sort of the same logic here, friends. Ready? How many times does 0 go into A? How many zeros can you put in A? That sounds very philosophical, right? It's like asking, how much air can I put in our classroom? It's undefined. There's like so much air. And there's only, it's like so many zeros, like an infinite number of zeros that you can divide into A. So we can't ever divide by A. Never, never. It's always undefined. All right, and our last one, it's going to come up a lot later as we do factoring and solving. If I have two numbers, folks, and I multiply them and I get 0, if a times b equals 0, do you believe that either the a has to equal to 0 or the b equals 0? Or possibly both, but definitely at least one of these has to be true. This one I definitely want to see in action. Let's say, for example, a is 5, and b I don't know, but I do know that when I multiply them, I get 0. Well, 5 times what is going to give you 0? Yep, see, that's how you'll get 0 for b. And the other way around is, what if I don't know what a is, but I do know I'm multiplying by 0 for b, and I get 0 out? Oops, I totally just put that in out of order. Cancel that thought. Let's put a 3 here. There you go, Mr. Brown. So what do I have to have here to multiply by 3 and get 0 out? And that also has to be a 0. So anytime you multiply two numbers and you get 0 out, either one of them is going to be equal 0 or the other friend equals 0. And we call that the zero factor property. All right, so now you know how we can deal with properties of equality and properties of 0. And the last big thing we need to talk about is, how do you play with our friends, the fractions? How do we add? How do we subtract, multiply, divide, and so on and so forth? So again, stuff that we've done from algebra and pre-algebra days, but it's really good to bring these back. All right, same rules apply. A, B, C, and D are real numbers, variables, algebraic expressions. And as you'll see later, B and D both can equal 0. And again, you'll see why. All right, rule number 1. If I have this fraction, A divided by B equals C divided by D, if they are actually equal to each other, we can do something called cross multiply, like that. Do you remember that from a little bit of algebra and maybe geometry? So therefore, if and only if A times D equals B times C. And that's called cross multiplying. Definitely want to see some examples here because it'll help out. I'll say I know that 3 divided by 6 is the same thing as 1/2. Right? I know that's true. So let's see if this works. If I do cross multiplying, how about 3 times 2? Does that equal the other cross? 1 times 6. And you'll see 3 times 2, 1 times 6, it does work. Okay, so the cross multiplying property works here. If a fraction equals another fraction, then you can cross multiply and those are equivalent. Property number 2. All right, this is an interesting one that I come across a lot. If you have a negative in front of a fraction, what does that mean? I know it's a negative number, but like, what's negative? Is it A or is it B or is it both? Well, the good news is there's a couple of choices. You can either say either the A is negative, but the B is not. Right? So a negative A and a positive B gives you an overall negative number. Or vice versa. Let's make the A positive or the B negative. So all three of these, 1, 2, 3, mean the same thing. Okay? But what if I said, well, what if both of them are negative? And remember, negative divided by negative is a positive. So negative A over negative B, the negatives cancel and you just get a positive. All right, let me find an example here. How about negative overall 4 divided by 7? Okay, that's a negative fraction. That should be the same thing as just saying, well, what if I took negative 4 and divided by positive 7? Oh yeah, that's the same thing. That's still a negative number. Or 4 is positive, 7 is negative. Again, that makes a negative number. Okay, for this second example here, we can say negative 2 over negative 3. The negatives cancel, and you get an overall positive number. Okay? All right. Now, this A over B for number 3, I have to figure out what that is for. I think that just means that if I have A over B, I can multiply the top and the bottom by the same number, and should still be equivalent. For example, A times C over B times C. That's equivalent to the original A over B, because you can think about C is common on top and bottom, so you can cancel or divide them out and get A over B. Not going to need an example for that one. Let's get to the serious stuff. All right, here's where we really play with fractions. I'm going to take A divided by B. I'm going to either add or subtract. That's what that plus or minus is. Either add or subtract. The good news is you do the same steps either way. And I get c over b. Now remember, when you add fractions, the first thing you have to remember is you have to have the same denominator in order to add or subtract them. If you don't, we'll work around that. That will probably be property number 5. But for now, they are the same, which is good. And because they are the same denominator, we can keep that one denominator and just literally add or subtract the tops. Okay, so adding or subtracting fractions, you need a common denominator first. Let's do an example of this one. How about 3 over 4 plus, I'll choose plus this time, 5 over 4. All right, so I'm going to double check. If I'm going to add two fractions, I have to make sure we have the same common denominator, and we do. Yay! So let's do that. We keep that same denominator on the bottom, and we just literally add the tops. I get 5 plus 3, and that simplifies to 2. Okay, so as long as you have the same denominator on the bottom, you can add or subtract them. But now if you don't, look at number 5. Look, I'm going to try to add or subtract, but do you notice now that the denominators are different? Okay, if they're different, we have to do a little bit of extra work first. We need to make sure we have the same denominator, though. So one of the ways that we're going to do that is we're going to make a common denominator by combining these two together. So I'm going to make a common denominator of b times d. b times d is good because both the b and the d divide into it, so they'll make a good common denominator. Now, in order to do that, I have to change both of my fractions so that they do have the same common denominator. So for the left fraction, it was a over b. Well, in order to get this new fraction over here of the denominator of bd, it looks like I multiplied the bottom by d. But as you notice from property number 3, if I multiply one of them, I have to multiply the other one. So I'm going to multiply the numerator also by d. So my new numerator becomes a times d. There we go. Let's do the same thing with the second fraction, folks. Now, in order to get from this d to bd, it looks like I'm multiplying the bottom by b. And if I multiply the bottom, I have to multiply the top as well to make it equivalent. So this becomes, I'll put it alphabetical, b times c. Okay, so now if you look at it, we now finally, yay, have the same denominator. So we're back to sort of property 4 right above. So we keep the same denominator and just we add the tops. This is AD plus or minus, whichever we were doing, BC. All right, this is a good one to show with an example, just because adding and subtracting fractions can be really tricky if we don't have the same denominator. All right, how about we choose, I'll do 3 over 7 minus, how about 2 over 3? Okay, we see we have different denominators. We have 7 and we have 3. We have to find a good common denominator. And just like the b's and the d's that we have, best thing to do is just take the b and the d and multiply them together to get a good common denominator. So why don't we make 21 as our common denom? Ready? So that means I'm going to change the first one, which was a 7, into a 21, and change the second one, which was a 3, also in 21. Now, what did I multiply the bottom left fraction by, the denominator there, to get 21? I multiplied by 3. So what do you think we're going to multiply the top by? A 3 as well. So now my new top should be 9. And 9 over 21 is the same thing as 3 over 7. All right, same thing on the other friend. In order to get this 3 to be 21, I multiply by 7. So multiply top by, you got it. So therefore, my new numerator on the second frac is going to be 14. We are so happy now. Look at that. We got the same denominator. Yay! So now we can keep the same denominator and just literally add or subtract the tops. Here we're subtracting. And we can do 9 minus 14 is a negative 5 over 21. Or look how I wrote it. You can write a big negative in the front as well. These are all fine. And there you go, friends. Again, maybe a review for many of you, but if not, great to bring this back and learn it again. All right, let's keep going. We're on a roll. Number 6. I love multiplying fractions. Multiplying fractions are easy peasy because you know what you have to do? You just literally bulldoze across the top and you bulldoze across the bottom. You do sort of a cross multiplying. That becomes A times C over B times D. Look how easy that is. Oh, wonderful. Ready? Let's get an example. How about 5/4 times 2/3. Sweet. All right, when you multiply fracts, let's just bulldoze across the top and do 5 times 2 and 4 times 3. And there you go. Now, we can talk more about reducing fractions, kind of like the reverse of what we did on property 3 up there. But I can reduce 10 and 12 because they both have a 2 in common, right? This is 2 times 5 and 2 times 6. So the 2's cancel, and I'm left with 5/6 is the final answer. But the main point of this one, friends, is just know that when you're multiplying fractions, you just bulldoze across the top and bulldoze across the bottom. Last one. Here we go. Let's divide fractions. All right, divide fractions is kind of cool. It's just like number 6, but you've just got one extra step that you have to do. Okay, in order to divide a fraction, dividing a fraction is same thing as taking the original fraction, the first one, and changing division into multiplication. And now you're going to, instead of dividing by c over d, you're going to change that into multiplication of d over c, what we call multiplying by the reciprocal. Have you heard that before? So dividing by a fraction is the same thing as multiplying by the reciprocal. And notice that we only take the reciprocal of the bottom, right? I didn't change the I didn't change the first fraction at all. He stays the same. And you do the reciprocal of the second fraction. Okay, now we have a over b times d over c, and you're back to step 6, or property 6. And we're going to bulldoze across the top and bulldoze across the bottom. Okay. So dividing by a fraction means multiplying by the recip. All right, last 2 examples for you friends. Can you go and try number 10a and b on your own? Pause the video, and I'll meet you back here and we'll see how you do. Good luck. All right, friends, ready? So for part A, here it looks like we're dividing. And we know now dividing by a fraction means that we're going to multiply by the reciprocal of this friend. So we're going to keep 7 over x the same, and now change the division into multiplication, and I'm going to take the reciprocal, or flip, the second friend. And there you go. Ready? Bulldoze, bulldoze. And I get 7 times 3. X and 14, they don't really combine well, so I just get 14 times x. Nothing much more you can do with that. And there you go. I do think there's a number I can maybe divide out of the top and bottom, because I see that they both have a 7 in common, right? This is 7 times 3, and this is 7 times, well, 2x, I guess, with the x. And look at the 7's go away. Go away. And you are left with, final answer, a 3 on top and a 2x on the bottom. Okay, dividing by a fraction, you multiply by the reciprocal. Let's see how you did on part B. Part B, now I'm adding. If I'm adding, I got to think about common denominator. But look, oh no, we don't have it. That's okay, we can find it. So why don't we multiply these 2 friends together, and a good common denom would be 15. So we're going to change each fraction, right? So let's take the x over 3, and his new denominator is going to be 15. And look what you did. What did you multiply the bottom by? So if you do the same thing, you should be multiplying the top by 5, and I get 5 times x. Okay, multiply top and bottom by 5. Now, how about the second fraction? It was a 5, now it's a 15. That means you multiply by 3. So multiply the top by 3. Oops. 3 times 2x. There we go. And now we're about to add. Do we have the same common denominator? Yes, we do. Yay! So let's keep that same denominator and just add the tops. And these are actually like terms. They're both 5x and a 6x. They both have x's, so if I have 5 and 6, I have 11 of the x's. And that's my final answer for 10b. How did you do? Congratulations, this is the end of P1. Finally, great job, everybody.